a lot of today's video deals with things that we've already discussed, but it's a really important video because it kind of helps you understand the idea of, wait a minute, when it's an acid, you know, how is there some base, how is there some hydroxide in there? Or if the pH is like 10, how can you measure the hydrogen ion concentration when it's a base? Doesn't that just mean there's a bunch of hydroxide in there and not any hydrogen ions? So, and the reason that happens is because even in an acidic solution, there's still some hydroxide ions. Okay, we'll talk about why here in a second. And in a basic solution, yes, there are still some hydrogen ions. There's just more hydroxide ions than there are hydrogen ions. Okay, and the reason that happens is that even in a basic solution or even in an acidic solution, water all by itself does what's called some self-ionization or some autoionization. They call it, the name doesn't really matter, which means that water just all by itself, a glass of water sitting there by itself, to a very small extent, all by itself will create hydrogen ions and hydroxide ions. And as long as those two are equal to each other, then it is a neutral solution. Okay, we'll talk about what that means here in just a second. Okay, so as long as the hydrogen ion concentrations and the hydroxide ion concentrations are equal to each other, then it will still be a neutral solution. A lot of times when we think about neutral, we say that it has to be a pH of 7. When you're at 25 degrees, that is correct. Okay, let's talk about what that means. So at equilibrium, you can write another equilibrium constant. These are both liquids. And so Kw, where the W stands for water, so it only is when water autoionizes, you get the hydrogen ion concentration times the hydroxide ion concentration. And at 25 degrees Celsius, and only at 25 degrees Celsius, is Kw equal to 1 times 10 to the minus 14th. So, since for every one of these you get one of these, those concentrations are equal to each other. So if we just take the square root of 1 times 10 to the minus 14th, we get 1 times 10 to the minus 7th. And then we find that, again, the pH of pure water, again, at 298 Kelvin, we'll talk about the temperature change in just a minute, is obviously equal to 7. Okay, we can not even estimate it. When it's 1 times 10 to the minus 7th, we know that the pH is exactly 7 and the pOH is also 7. So again, things that we've already discussed, that the pH plus the pOH is equal to 14. Just like you can have a pKa and a pKb, you can have a pKw as well, and that's also equal to 14. The pH plus the pOH is also, again, this one you don't see too much, but that is technically something that we could use. Okay, now it should be carefully noted, though, that if you're not at 298, Kw does not equal 1 times 10 to the minus 14th. Okay, which means that if you're at a temperature other than 298, pure water is not going to have a pH of 7. Okay, because remember that pH is a measure of the hydrogen ion concentration. But water is still considered neutral whether the pH is a little bit less than 7 or a little bit more than 7, because, again, the hydrogen ion concentration is equal to the hydroxide ion concentration. Okay, whether water is neutral or not is dependent on the concentration of these ions. It's not dependent on the pH. So a lot of times you see, oh, it's a pH of 6.5. It must be acidic. Not necessarily. Yeah, it's a good estimation, a good prediction, but not necessarily, okay? If the pH is 6.5, it is possible that the hydrogen ion concentration and the hydroxide ion concentration are still equal to each other. It could technically still be neutral, okay? Now, if it's acidic, what makes it acidic? It means that the hydrogen ion concentration is greater than the hydroxide ion concentration. Okay, and if it's basic, then the hydroxide ion concentration is greater than the hydrogen ion concentration. Now, why does this happen? Why does that pH change? Okay, first of all, it's because this dissociation of water this breaking one of these hydrogens off and creating a bond here is an endothermic process, which means that delta H is a positive value. And if delta H is positive, we know that we treat heat as if it were a reactant. Okay, and what happens if you raise the temperature of this solution? Well, of course, the reaction is going to shift to the right, and you're going to create more hydrogen ions and more hydroxide ions. And what does that do to our pH? Well, if you increase the hydrogen ion concentration, of course, the pH is going to go down. Okay, so at a temperature greater than 25 degrees Celsius, anytime you're above room temperature, that's going to cause an equilibrium shift to the right, and that's going to make the pH of the solution go down. But remember, it's still going to be neutral because these two are still going to equal each other. Okay, but the pH is going to go down. So at a lower temperature, or at a higher temperature, the pH is lower. Okay, and likewise, if you lower the temperature, so at 10 degrees Celsius or 0 degrees Celsius, what happens? That makes the reaction shift back to the left, and therefore the hydrogen ion concentration is going to go down, which means the pH is going to, of course, go up. So at temperatures, so if it's less than 25 degrees Celsius, the pH of neutral water is greater than 7. Okay, because again, the reaction is going to shift to that left-hand side, reducing the hydrogen ion concentration. And of course, if it's more than 25 degrees Celsius, the pH of the neutral solution is going to be less than 7. Okay, so since it's an endothermic process, think Le Chatelier's principle. If water dissociates more, the hydrogen ion concentration will increase, causing the pH to decrease. This makes it seem like water at a higher temperature is acidic, but remember that as water dissociates, the hydrogen ion concentration increases, and so does the hydroxide ion concentration. So again, it's still a neutral solution. Okay, so at 10 degrees Celsius, the pH is the pH of water greater than, less than, or equal to 7. Explain. So if you're less than 25, you've removed some heat. Again, come back up here, and that's going to cause that shift left to occur, which means the hydrogen ion concentration is going to go down, which of course means the pH must be greater than 7. Okay, so a shift to the left causes the pH, or let's start with the hydrogen, causes the hydrogen ion concentration to go down, so the pH is greater than 7. All right, so the problem is there's lots of different equations that we can get here, okay? We know that we can take the Ka value and multiply by the Kb value, and that equals 1 times 10 to the minus 14th, again, at 298. And remember, the Ka and the Kb values are different equations. It's when the acid reacts with water to form the conjugate base, and it's when the base reacts with water to form the conjugate acid. Okay, that we can multiply those two values together to get 1 times 10 to the minus 14th, and they also say that that 1 times 10 to the minus 14th is also equal to Kw. Okay, and then if we take logs of all of those, you get the pKa plus the pKb, just like pH and pOH equals 14, which is also equal to the pKw. Okay, this is what the equation sheet looks like on the AP exam. Okay, and most of this, I think pretty much all of this, we have now seen. Okay, I don't see anything on here other than this equation right here, which we'll get to. Okay, because that's a pretty important one as well. But pretty much everything else on there are things that we have now discussed. This is what we were just talking about right here. Again, only at 25 degrees Celsius. Okay, there's the Ka expression, there's the Kb expression, They have Kc and Kp on there. Again, that helps you make sure that you write those expressions correctly. If they ask you for it in terms of concentration or in terms of pressure, you've got to make sure you do those correctly. Okay, and then there's all the pH, pOH, pKa, pKb, all that stuff down here. Okay, and then again, there's that Kw, which you can turn into pKw as well. So lots and lots of different equations. And again, this is not one of those things where it's like, oh, so I don't need to know anything. All the equations are here. I'll be fine. Okay, and yeah, great, the equations are there. But if you don't know how to use them correctly, of course that doesn't matter. Okay, so really, really important to know these are the equations and this is how you use them correctly. Okay. And so again, the whole point here is to help you understand why when there's a base do you have hydrogen ions, and why when you have an acid do you have hydroxide ions, because water does this. Okay, because water autoionizes in an endothermic process. Okay, delta H equals a positive value. And when that does that, it doesn't matter whether you have an acid or a base. You always have some hydrogen ions in there, and you always have some hydroxide ions in there.